Okay, welcome back. We're going to look at a couple examples of graphing transformations of sine and cosine in this second video. So we're going to start with this first example where we have to sketch the graph of y equals 3 times sine of 1/2 x. Alright, so referencing those steps we had before, we want to first identify our amplitude. The number in front of the trig function is we're referring to as capital A. That's positive 3 in this case, so our amplitude is 3. That means our highest points are going to be at height 3, our lowest points are going to be at height -3. Second thing, we want to identify the period, which is determined by the inside of the trig function. And what we're looking at in these couple of videos is either a times sine or a times cosine of bx. Alright, so what we want to know is our period, which as explained before is going to be 2 pi divided by b. The number b for this first function is 1/2. Alright, so we're going to plug b in here, so the period is going to be 2 pi divided by 1/2. And then we just want to simplify that expression. Remember, when we divide by a fraction, we multiply by the reciprocal, and we keep change flip, meaning we keep the numerator alone. We change the multiplication to sorry, I said that backwards. We change the division to multiplication, and then we flip the denominator. So that's going to be 2 over 1. So that's just 2. 2 pi times 2 is going to give us 4 pi. Alright, so the period for this first example is going to be 4 pi. And I have some graph paper below which we're going to sketch this graph on using the 5 key points for the sine graph. But what we're thinking about doing here is splitting the interval from 0 to 4 pi up into 4 equal pieces. So cutting that in half, we're at 2 pi. Cutting that in half, we're at pi. 3/4 of the way is going to be 3 pi for this example. So at those 5 endpoints of those 4 subintervals, we're going to have our 5 key points, which we're now going to sketch. And then we can repeat that over every other interval of length 4 pi. So from 4 pi to 8 pi, or from 0 back left to -4 pi, and so on and so forth. Alright, so I'm going to scroll down. I have some graph paper that we're now going to plot this function. Sketch the graph of it. Okay, so got some empty graph paper here, and I've got the scale on the x-axis appropriate for this one. Alright, so again, the sine pattern, or if we have to remind ourselves what that looks like, I'm just going to flip over to Desmos here. The sine graph starts at 0, 0. Alright, the normal sine graph goes up to height 1 at pi over 2, comes back down to 0 at pi, down to negative height y equals -1 when x is 3 pi over 2, and back up to 0 at 2 pi. So that's our basic sine pattern. We're going to repeat that now by adjusting the amplitude and adjusting the period here. Alright, so we were going to go from 0 to 4 pi, so that's where one cycle is going to happen. We're starting at 0, 0. Alright, at height, let's do the end and then the middle, and then we'll go to the quarters. So at 4 pi we're going to be back to 0. At 2 pi we're at 0. Alright, between 0 and 2 pi, halfway between those, we're going to be at our highest point, which is going to be height 3. Alright, so we're going to put a point at height 3 when x is pi. Alright, when x is 3 pi, halfway between 2 pi and 4 pi, it's 3/4 of our period, we're going to be down at height -3. Alright, and then we could just extend this pattern going left and right. So if we were going to continue this going left, we would be going downwards down to height -3 at negative pi. If we're going to go past to 5 pi, we'd go back up to height 3. Let's draw the first cycle and then we can extend it. So again, the 5 key points were the ones we drew at first. So we're going to go up and down. Just do our best job to connect the dots according to that pattern. And then we would just keep going to the right. And then starting at 0 going left, we would keep continuing that pattern on. Alright, so this right here is just a freehand sketch of the graph of y equals 3 times sine of 1/2 x. Alright, we'll do the next example that we have listed in the remaining time here. But again, it has the key points plotted, once we know those 5 key points, we can just extend it going left and right in intervals of length corresponding to the period for this function. So in this case, it would be length 4 pi. All right, I'm just going to scroll back up for a moment, and then we'll continue on below here. The next one we want to do is y equals negative 4, times cosine of pi x. So let's write that down below, and then we'll start to analyze that. So the second example we want to look at is negative 4 times cosine of negative pi x. All right, so now we've got to, again, go through the same steps. Identify the period, the amplitude, and then the period. So again, the amplitude is really the absolute value of this number. So our amplitude, capital A, is going to be positive 4. The negative in front is going to tell us that that's going to reflect the graph over the x-axis also. So it's going to be upside down from our normal cosine graph. All right, and then I don't know why I put a negative on the inside of that. Let's pretend that wasn't there. I'm just erasing that quick here. So it was just pi x on the inside. All right, so we want to know what the period is next. So again, our number b in this case is pi, actually. All right, so when we write down the period, it's always according to this formula, 2 pi divided by b. Again, we just want to know when pi x in this case is equal to 2 pi, and solving that equation is equivalent to plugging in pi for b here, which simplifies just down to 2. So it comes out to exactly 2. It comes out to an integer in this case, not in terms of pi. So our period is length 2, meaning we're going to complete one cycle of a reflected cosine graph with amplitude 4 over the interval from 0 to 2. Okay, so again, thinking about just on the x-axis here, always starting at 0, we're going to go out to 2 this time, cut that in half, we're at 1, cut that in half again, we're going to be at 1/2. 3/4 of the way down is just exactly 3/4 for this particular function. All right, so let's get some graph paper, and then we will plot that graph using the 5 key points for cosine. All right, so continuing, let's plot our key points down below over, again, intervals of size 2. All right, so I got some graph paper here with an appropriate scale. So one thing we got to keep in mind is cosine normally starts at height 1. All right, then drops down to 0 1/4 of the way through its period, down to negative 1 halfway through, back up to 0 3/4 of the way through, back up to 1 all the way through. We are going to be reflecting this over the x-axis, so we're going to start down at the negative value and then creep up for this example. All right, so again, our amplitude for this problem was 4. Need to make this a little bit smaller to fit this on the recording screen here. Apparently even a little small. Okay, that'll work there. All right, so we're going to go, starting at 0, we're going to go down to height negative 4. Again, our period was from 0 to 2. So halfway through that is 1, and then we're going to go at height 1/2. All right, so that's right here. All right, so that's going to be 1/2, and then 3/4. My grid didn't work out perfectly here. That's okay. So 3/4. Again, we're just getting a sketch here. We can plot this with Desmos or graphing calculator as needed too. All right, so this is going to be where we are at height 0, all right, at 1/2. Halfway through the period, which is going to be at x equals 1. This is going to reflected cosine graph, so instead of going down to negative 4, we're going to be up at height positive 4. 3/4 of the way through, we're back at 0. Full through the period at the end of the first cycle, we're going to be down, in this case it's a reflection, back to height negative 4. And then we would just keep repeating this pattern. So the next period, or the next cycle we would graph this over would be from 2 to 4. Halfway through that's 3. And we'd be at 2.5 or 3.5, 3.5 or 2.5. So keeping on plotting these points, we'd be at 0, above 3, we're at height 4. Back to 0 at 3.5, back down to negative 4 at height 4. Going backwards to say -1/2 or -1, we'd be at 0 and at 4. So we got a bunch of points plotted. The main ones were the first ones, which I'm going to connect straight off here. All right, we're going to be going down, or from -4 to 1/2. All right, and then up to height 4, back down to 0 at 3/4, back down to -4 at 2, and then we would just keep on repeating the same pattern, going to the right and likewise going to the left. Again, my picture's not perfect here. We can use a graphing calculator or Desmos to get a better result, but that is a decent sketch of y equals -4 times cosine of pi x. All right, let's just quick verify these graphs using Desmos, and that'll be it. All right, so I have these actually loaded up. There's our graph. All right, so -4 cosine pi x. All right, notice it's kind of a little bit smushed in. Multiplying by a number bigger than 1 on the inside in terms of function transformations is a horizontal compression. All right, horizontal compression means we're going to see more of it. All right, so that lines up with what we came up with. Looking at y equals 3 times sine of 1/2 x, multiplying by a number on the inside that's less than 1, multiplying your input by a number that's less than 1 actually does a horizontal stretch. So it sort of seems like we see less of it. It's stretched, pulled away from, if you will, from the y-axis compared to the cosine one, which was kind of crammed in or compressed in towards the y-axis. Notice the lowest and highest points again were at -4 and +4. For the second example we did, the amplitude was 3, so our highest points are at height 3. Our lowest points are at height -3. Hope you found this helpful.